Hello everyone, welcome to this workshop for HACXMAS 2021. We're going to be covering TensorFlow, specifically being fashionable with TensorFlow. If any of you haven't met me before, my name is Tom. I'm a GDSC lead at the University of Portsmouth. I also happen to work at HACXMAS, who I believe you've met my colleague Prince earlier this afternoon. I work with him as a data scientist. I'm just going to sort of wait a little bit just for people to come in, and then we will get started. Hello, P. Very fantastic. Then I think we will start now. First, sort of a little bit of an introduction into sort of what TensorFlow is. So TensorFlow is an open source machine learning and artificial intelligence library. It was created by Google Brain in 2015. They're a team that comes under Google AI in general, and their main focus is they're working with sort of neural networks and deep learning. They're trying to essentially emulate the human brain. So TensorFlow is a library. It can be used in many languages, in Python, Java, JavaScript, C++. They're the main four it can be used in, but very commonly it's used in Python. And for this workshop and this example, that's what we're going to be working on today with Python. So great, we know what TensorFlow is. So what can we actually do with TensorFlow itself? So here are some good examples of projects that have been done with TensorFlow in the past. So you can use object detection in video. So here's an image of a project where someone's trying to detect vehicles on the road. Another good use of TensorFlow is in sort of, here's an Amazon Alexa. I know it's a bit ironic because we're a Google event, but Amazon Alexa and sort of personal assistants is a really good use of thing. And also a little bit of foreshadowing. This is a picture of a shoe. And we can do object detection on stationary objects. And it's a little bit of foreshadowing for the future. So cool. So this is going to be a practical workshop. So I hope everyone's got their laptops ready. We're going to be using TensorFlow through Python. So it's going to be, as I said, a practical workshop. So we're going to be showing you how to essentially do a demo in TensorFlow. So at first, installing TensorFlow is relatively easy. So you're going to want to open up your terminal of choice. Now, if you're on Windows, that might be PowerShell, CMD, or the Windows terminal. If you're on Mac OS or Linux, that could purely be, I mean, there's a ton of terminal applications. You can use the default terminal one. But if you open that up, and then these are the commands that you're going to need to install. Pip is the Python package installer. And so if you've got Python installed, you can just run these commands to make sure you install TensorFlow, and also two other libraries that we're going to be using, that being NumPy and Matplotlib. NumPy is essentially it's a mathematics and array sort of. It's just a general utility library that's really useful for TensorFlow, and the other library, Matplotlib, is used for plotting lots of lovely graphs. If everyone sort of does that, and I'll give you a minute or so to install it. If anyone has any problems with this, please put them in the comments or in the TensorFlow chat on the Slack. And then, yeah, so installing TensorFlow is relatively easy. You just run that pip command. Should look something a bit like this. takes roughly, this was done, took about 2 minutes to install. At the end, it will look something horrible like this, and at the end, it will just kick you back to your terminal sort of command line. And once that's sorted there, you'll have TensorFlow installed. Actually, while we wait, a raise of hands of anyone in the comments. TensorFlow. Okay, interesting. So you try. Was that after doing pip install TensorFlow, Zahib? But yeah, if anyone else has any other problems, please put them either in this chat or in the TensorFlow chat in the Slack. Essentially, you're going to want to see if you can get TensorFlow installed for the rest of this workshop. You did install pip. Have you installed pip before TensorFlow? That's cool. So was that did you just do pip install TensorFlow? Like I can go back to the slide earlier. This one here. So the just pip install TensorFlow. If you're using Python 3, have you tried pip free install? Because I know some instances you have that problem there. So yeah, if you have any problems, please put them in the dollar just represents the command line, the terminal command line. So you would just type, if I go back to my slides, so just pip space install space TensorFlow. Yeah, if all of the code that we're going over here is hosted online. So we're going to move forward. Zahib, if you go to the Slack and the TensorFlow, one of my friends will be able to help you with that fully. You can put in sort of a bit more detail there. So if everyone else has gotten sort of TensorFlow working, fantastic. Let's use it. So we're going to use a little bit of a scenario. So fun fact, we as a collective, we own a fashion shop. I'm not sure if you knew that, but we do. We're very, very fashionable people. As you can see, we've got very, very fashionable clothes. We've got Supreme. We've been to the Paris fashion show. We've got whatever that man is wearing. We're very, very good at what we do. But we have a slight problem. What is this? Anyone know? I don't. I have no clue what this is. This is clearly a question that no mortal in the history of the planet could ever answer. What is that? I have no clue. So let's use a powerful tool to work out what this is. Let's use a neural network. So if you've got TensorFlow installed, you go over to your Python IDE of your choice, and we will start making a neural network. As I said, all the code here is online. I'll send you the link to it at the end, so no worries if you fall behind. So we're going to be using the Fashion MNIST dataset. It's essentially a lot of pictures of fashion items which have been labeled with what they are. And we're going to develop a neural network to essentially tell us what item of clothing we're looking at. So it's a form of computer vision. So here on the first slide, should be able to see that fine. This is the first code you're going to want to put into your Python IDE. You're just importing TensorFlow, NumPy, Matplotlib, and we're also just going to print the TensorFlow version just to make sure that it's been installed properly. So if you were to execute that, it should just print out whatever TensorFlow version you've installed. 2.5, I think, is the one I have installed on my laptop. But But yeah, so once you've gone through that, just go through. It should be fairly easy. So yeah, the next line after we've gotten the TensorFlow library and the other libraries that we're going to be used installed, we are then going to import the HACXMAS data set. So these are a few lines of code, and I understand that if you're not used to Python, these might look a bit horrible. Essentially, we're loading in from tensorflow.keras.dataset.fashionmnist. It is part of the TensorFlow library we've just installed. It's essentially a core dataset. And the next line is essentially we're splitting that dataset we install into two tuples of data. It's 4 arrays. So we have our data, and we're going to split it into training data and testing data. And we'll go over more about sort of what that entails later. But essentially, what we're doing is we're getting the images and the labels, and we're then splitting them into 2 sections for use later. So I'll give you just a little bit of time to copy that down. Again, as I said, all of this code is hosted online. You'll be able to go to it with a link that I will post you at the end. Just give you a little bit while people are working on that. This is what the data looks like. I know it might be a little bit hard to see. Essentially, that is just picture after picture after picture of black and white clothing, and each one of those is allocated a label, and that label could be basically whether it's a jumper, whether it's an ankle boot, etc. And so those labels are numerical, though. So we have essentially there are different classes. We have a class of 0, 1, 2, up to 9, and so we have 10 classes, different types. And these classes, obviously being numeric, that's no fun. So we want to know exactly what they mean, and so we're going to basically create a list of the different class names, and essentially so we don't need to figure out what clothing type 7 is every time we run a command later. For context, every line of code that I'm showing you, just put it after the previous one. It's quite a linear tutorial. Again, if anyone has any questions at any point, please put them in the comments, and either myself or the other HACXMAS team will get back to you as soon as possible. All right, so now that we have the different class names, we have the class names, we have some clothes, but what does the data that we've just installed actually look like? Sort of what do we actually have? And so we can use the library installed earlier, matplotlib, and essentially we're going to create a plot of the first image in the train images array that we've just imported. And so if you go through and you write these, we're just going to create a temporary quick plot of what the first image in index 0 looks like. And if it is working correctly and it's the same as when I did it, you should get this. Fantastic. It's a shoe. So this is the image that we had in position 0. And if we go back to here, it is quite difficult to spot. Actually, this image doesn't show index 0. Whoops, my bad. But yeah, so we have our shoe, and that's fantastic. It's a shoe, but we do have a slight problem in that, as you can see, the values of this shoe on the plot go from 0 to 255, which a lot of the time wouldn't be a problem if you're just plotting it, but because we're going to be plugging this data into a neural network, we need to scale the values to a range of 0 to 1. We need to normalize the data values for feeding them into a neural network. And so essentially we need to pre-process all of the data. So both the training and the test data that we pulled from earlier, we need to basically normalize them. And that's quite straightforward. Essentially, you just divide the values by 255. And so they're ranging from 0 to 1 in a normalized state. And so you just wanted to set your train images and your test images that you've downloaded from TensorFlow earlier, and you just want to resave them as 255 divided by 255.0. It needs to be a float value. Okay, now I've given you a little bit of time to do that. The next step that we've been going on is we want to, now that we've downloaded our data and we've pre-processed it, we want to make sure that the data is what we expect and is of the right classes. So we're going to use our lovely friend matplotlib. I'm going to leave this code up a little bit longer because it's quite a few more lines. But essentially what we're going to do is we're going to loop through the first 25, I think that says, yes, 25 images in the training data set, and we're going to map their captions to it, and we're just going to essentially check that yes, it is as we expect. And so I'll give you guys a little bit of time to copy that down. If anyone's struggling or having any problems with this, please let me or a member of the team know through either the YouTube comments or in our Slack. Yeah, I've just checked the YouTube stream. I can't hear myself, so I would try and refresh your YouTube browser and see if that works. All right, and so with that, once you have written down those lines of code, you should, once executing this, you should get a very nice looking plot, just like that. That's fine, Ryan. You should get a lovely plot looking on this, which shows the images. And as we can see, the image in index 0 is indeed the shoe that we thought it was earlier. It's in fact an ankle boot, which is, I believe, class 9. And that's going to come back to bite me a bit later when I got it wrong, but that's fine. So you can see the first 25 images. We can see how in the training set they have been labeled. And essentially what our objective is we're going to take this, build a neural network out of it. And then after we have a working neural network, we're then going to test it on the test data, which is not labeled. Well, we won't pull in the labels, and then we can verify the labels later to make sure that we have a good accuracy. So fantastic, we have some pre-processed data. Let's build a neural network. Now, before we go and build a neural network, I just want a sort of a show of hands in the comments or in the Slack. Who here knows about neural networks? Because it's quite a complex topic. And so I just want to sort of, if anyone has any questions about neural networks before we go in and start making one, just want to answer them, really. Make this as entertaining as possible and also as educational as possible. So yeah, any questions, if you know what a neural network is or you don't, just put in the chat. Yeah, sure. I could go over briefly what neural network is. Packages and why are the libraries we're using. If I very quickly go back to here, we're using TensorFlow, NumPy, and Matplotlib, which you can see the install for there. This is for anyone who's joined us. Like Riam, all the code for this is online, and there's a tutorial going over sort of how to do this. So if you do get behind, or if you don't fully understand it, I will link to that in a bit. So, okay, to answer you, P, what is a neural network? It's quite a loaded question, but I can go over it sort of quite briefly. Essentially, a neural network is a form of deep learning, which is a form of machine learning. And essentially, what we do is we're trying to mimic slightly how the human brain learns. And so in the brain, you have these little cells called neurons, and the neurons are all connected to each other via your brain's neural network. And so the name just ripped straight from that. And essentially how your brain remembers memories is you have a specific pattern of neurons that will fire in a process called activation. And essentially each memory that you have is a specific series of these neurons activating. And so some very smart scientists and engineers back in I don't actually know when neural networks were first invented. I think the theory for them came out like maybe the 70s or the 60s, 70s, sometime around then. But they've only really been properly implemented in the last 20, 25 years. There's a very good example of a computer scientist who I would highly recommend you follow on Twitter called Yann LeCun. He is Facebook's head of AI, Meta's head of AI now, and he's also the person who invented the convolutional neural network. These eminence data sets were actually created by him, so I'd recommend. But essentially what we're going to do is we're going to try and mimic how the human brain works. We're going to create some neurons, we're going to connect them up, and we're going to basically train our model to essentially learn paths of neurons that an image will be related to a path of neurons that it can take. And essentially what we're going to do is we're going to train our model like the brain trains itself to memorize things. I hope that's good enough. I'm by no means an expert on this topic, so if you have any other questions that I can't answer, please put them in the Slack, and I will endeavor myself to try and find the answers for you. But I hope that was a good explanation. All right, fantastic. So we're going to move on to the next slide, and we are going to be building a neural network. So we're going to be using TensorFlow Keras's sequential, which is essentially it's a pretty standard neural network where you have sort of sequential layers, and we're going to define it with 3 layers. We're going to have a flattened layer, and then we're going to have 2 dense layers. So the flatten layer, the first layer in the network, the TF Keras layers flatten, essentially will take our input image. And so our images that we saw before, they are 28 by 28 pixels. So normally in a computer system, that will be stored as a 28 by 28 2D array. And essentially what we're going to do is we're going to flatten them to a one-dimensional array of 768 elements. So essentially what we're going to do is we're going to compress this 28 by 28 dimension array down into one line. So essentially you're going to stack them one after another and just flatten them down. It's not a learning layer. It's purely reformatting the data so it can be essentially nicely worked on later. So after the pixels are flattened, the rest of the network is a sequence of 2 TF Keras layers, dense layers. Pardon me. So these are what we call densely connected neural layers, or fully connected neural layers. Essentially what that means is every node in the layer, so in this first layer you can see the number 128. This dense layer has 128 neurons. Every single one of those neurons is connected to the previous layer and the following layer. And so it's a fully connected dense layer with the maximum number of connections, with 128 nodes, or well, the nodes are also the neurons. So you think about this layer, it has 128 neurons that we can pass the data through. The second and final dense array, it has 10 neurons, and these 10 neurons, to my understanding, correlate to the 10 classes that we're trying to classify. And so this is going to return something called a logits array, and the logits array is basically going to tell us how likely this input is to be each of our 10 classes. So let's say our class, our last class, our 10th class, which is actually index 9. Let's say that is our ankle boot, and we pass it a picture of a jumper. That's theoretically, as long as our model works, which it should do, is going to have a low sort of correlation to that class. I know that's a lot of theory, so if anyone has any questions, please ask. I also missed out the ReLU, and that's the ReLU is the activation function that I mentioned earlier. So in the brain, how the sequence of neurons being activated. This is how we mock that, and that's ReLU. That's just one of a number of activation functions. It's one of the more simple ones. Basically stands for, I believe it's rectifier something unit, rectifier learning unit, maybe. I might be wrong with that, but yeah. If anyone has any questions, go free. Throw them at me. If not, I will move on. So the next step we have is we've built our model, but we just need to make sure it's ready for training. And so we're going to compile our model before running it. And so essentially what we need to do is we need to basically allocate it a number of parameters that will be passed later. So we're going to pass it an optimizer, a loss function, and basically the metrics we're going to use. So the optimizer is essentially, it's how the model is updated. So the model will see data and how stuff is pulled out of the loss function, which I'm going to go over in a second. And essentially the optimizer, in this case, we're using an optimizer called add emitter, again, a fairly standard one. Essentially, it's going to take in data and it's going to update the model as it goes along. The next line, which is a fairly long line of code, this is our loss function. And so essentially, this is measuring how accurate the function is. So loss in a model is a statistical term, and essentially it means that over time, with more training, the model can sort of lose its accuracy. And so essentially what the loss function does is it measures how accurate the model is during training, and you're essentially trying to minimize the output of this function. So you're steering the model towards more accuracy. And so that loss function is used in combination with the optimizer. So essentially over more and more iterations, push the model to be more accurate. The final parameter that we're going to pass into the compiler is the metrics. That's basically just essentially what we're interested in. Essentially, what we're going to monitor in the training and testing data while it's being trained. And so essentially, we just want to know how accurate our model is. So we want to know when it's being trained, and then when it's tested, when it's being developed, how many of the images is it correctly classifying? So if it sees an ankle boot, is it telling me it's an ankle boot, and etc. And so that's essentially what we want to do there when we're building that. So once we've compiled our model, we can then run it, and running the model is basically as simple as that. We're going to call model.fit. Model is the name of our model. Fit is just the training function. So we're going to pass it the training images, which is all of our lovely pictures of clothing, our training labels, which are the numeric values that we that we talked about earlier, and then we're going to give it 10 epochs or epochs. And essentially what this means is that we're going to feed the training data into the model. It's then going to learn how to associate those labels with those images over and over, and it's going to build up that network of 128 neurons into 10. And then essentially we're going to then use this model, and the 10 epochs just means we're going to basically iterate over it 10 times. And so once we've got that and we run this code, we're then going to see this lovely line of numbers. And so this is the actual training of the model itself. This is just how TensorFlow shows it off. And as you can see on the right-hand side, you can see the accuracy value, the metric that we said we want to we were interested in. And so essentially over time, we are, as you can see in the epochs, it is going to, after each epoch, it's going through the model, it's getting more accurate, the loss function is being minimized, until we get to a point at the end where our model has an accuracy of just over 91% on the training data, which is fairly decent. Most sort of in production, fairly competent neural networks are in the range of about 80 to 90%. So ours being 91% is at the upper range of that. And so clearly with the data we've given it, we've formatted it well enough that it is definitely decent enough. And so after we have trained our model, we can then evaluate our model using this function. And so we're going to give it the test R. After we've trained it, we're going to give it our test data that we then test it on. And we're going to run this line of code. I don't have an image of this line of code running, but if I remember correctly, it's about 88%. So it's the actual test accuracy of our model is slightly lower than our training accuracy. Does anyone have any idea why that might be the case? I'll give you a little bit of time to maybe think about that. Why you think that our model might not be as accurate when we do it on the test data? No takers? That's perfectly fine. So the reason why we're getting a lower testing accuracy than training accuracy is because of something called overfitting. Now, overfitting is a kind of a buzzword in data science, but essentially Okay, sorry, I didn't see that message come through. Predicting something that it hasn't seen before. Yeah, pretty much. So overfitting essentially means that the model has fit itself too much to the training data, and so in the training data there might be some outliers. There might be something that it's not very good at predicting. There might not be enough data on a certain topic, so it extrapolates what it has in the training data. And so when it comes to the testing data, it's going to say, oh, well, in the training data, this was what we did. And that might be fine for one case, but it won't be fine for all. And so this is overfitting. In this instance, we had 3% overfitting, which I'm going to be honest, isn't too bad. I've seen models with about 20, 30% overfitting in the past. We can live with 3%. And we can think about improving this at a later date. and we'll go over that a bit later, how we could improve this model. But once we've tested our model, and that's great, we have a model. So great, we have a model, and I'm pretty sure it works. It looks pretty good. So, oh, what's happened to my slide? There we go. So let's use our model. So, do you remember back to image 0? And this was our shoe. It was specifically actually an ankle boot. So let's write some code to test whether our model agrees that this is actually an ankle boot. And so with our model trained, we can use it to make predictions. And so we're going to essentially build a probability model out of our model. The model itself outputs something called logits, and the logits are basically the probability, well, not the probability, but sort of the likelihood that each item is each classification. We can build something called a softmax layer, and essentially we can convert these logits to probabilities, which are much easier to interpret, and the human mind understands probabilities a lot more. So we can write this code here, and we're going to create a new sequential model. We're going to merge our model with a softmax layer, and the softmax layer is going to be the final layer in our neural network. And then we're going to predict using our test images, our predictions, and we're going to then return essentially the first prediction that we make. And so if we go forward, you should get a return of 9. At least I did in my instance. It depends on how your neural network is. It's can be fairly random in some cases. And if we were to go back and check, and I promise this is the case, the element in place 9, which is actually 10 because of our array starting at 0, is an ankle boot, which is what that is. And so our model seems to be working really well. So great, we have a working model, we've built it, we've evaluated it, it seems to be working. Let's visualize this, because as fun as numbers are, pretty colored graphs are much nicer. So I'm going to leave these next few slides up for a bit, because as you're about to see, these are helper methods for later. So this is a function. This is a function called plot image, and essentially what it's going to do is at a later date we're going to show an image, and then in either blue or red we're going to say whether its label was correct or not. And so yeah, this is some pretty hefty code. I will drop this into the I'll drop this into the Slack, the TensorFlow Slack, so people can copy and paste it. So just give me a moment here. So in the TensorFlow chat, here is the first function. Here, and so I'll leave it up for a little bit. If anyone wants any more sort of a description of what this does, I can go over a bit more in detail. But essentially the gist is it's just a helper method where we're gonna basically pass in an image and what its label is, and we're going to check whether it's right. There we go, and just dropped it in there. Oh, that the 3 backticks at the start and the back are just the text color formatting. So if you remove them when you actually put it into your code itself. So we've got plotting image. Great. The next function we want to use is the plot the value array, and essentially what we're doing is we're plotting the I'll drop this in here. If someone in the chat team can put that in the YouTube, that'd be great. And I will dump it in the thing as well. And so what this is doing is we're going to be taking our essentially the values of how much it is in each. Essentially, we're going to take the value of how likely an image is to be in each class. And then we're going to plot that. And so once we've got both of those done, and I promise only one more big block of code left, we will then move on to our final major function, and this is this. And this is essentially what we're doing is we're going to take the first 15 test images, and we're going to run both of those functions on them, and then we're going to plot them. And so, yeah, again, I do apologize that these methods are quite long, but if you can copy and paste them from the chat, that would be great. And so once you've got those three methods written, we can run this method, and this is what it should look like. And so this is our model running on our test images. So we can see that in our first case, we have a shoe come in. We think that it is an ankle boot, and we are 100% certain it's an ankle boot. As you can see in category 9, which is ankle boot, there is 100% in the blue. The next one is a pullover. It got 99% accuracy. Our trouser, it got 100% accuracy, and onwards. And it's getting fairly high accuracy until we get to a shoe. And it's a fairly pixelated shoe in the bottom left. Our model seems to think it's a bag. This is that 10% where it's going to get it wrong. And this is just due to the input data we've given it. It just hasn't been given enough input data to figure out that that is in fact a shoe. And it thinks it's a bag for whatever reason. And so building on top of that, we essentially are going to want to improve that at a later point. But this is fine for now. We can also, if you want, so we've got those first 15. We can also, this code here is essentially the same as before. It's just been taken out of a loop, so it only will test a single image, and you can essentially test that a single image works. So I'm just gonna, again, put this in the to post. So yeah, so essentially the idea is that we can then use this code here to basically, yeah, decide that decide whether a single image, fantastic, or you can either say supercalifragilisticexpialidocious. It's working well. So in all, that's sort of the end of my workshop. So in summary, we've been very fashionable. We've learned what TensorFlow is. We've covered what TensorFlow can be used for. We've built a simple neural network. We've evaluated it and tested it and shown its results. And we've gotten so good at fashion that all of you out there watching this can probably put this talk on your CV and become CEO of Gucci, I would say, in my opinion. Gucci might disagree, but hey, I would say. So yeah, thank you so much everyone for coming. If you have any questions or need help, please @ me in the TensorFlow Slack channel. That is #TensorFlow in the Slack. And to learn more about TensorFlow, you can go to tensorflow.org/tutorials. On that page, you'll see a link to a tutorial called the Keras Basics. I will go over that in a minute over questions. The code we use today can be found here. It's under the tutorial called Keras Basics. It goes over how to use the fashion MNIST data set. All the code I've taken here is taken from there. So yeah. So on to any questions, and I'll start with Lena's question. How would you choose the parameters of a neural network? So this is sort of an area of a bit of contention in data science. Essentially, there are some sort of, pardon me, so for Yelena, there is essentially there are multiple different types of neural networks, and for each of them, there are sort of some pretty standard parameters that you want to pass in. But the best way to test it is to essentially you try it, and then there's this technique called hyperparameter tuning, when essentially you will take a grid of values. Let's say you have 10 numbers that you want to find the best input for, and you want to iterate them over, I don't know, between 0 and 100. Essentially what you do is for every single one of the combinations of every single one of those values, you'll build a massive grid for all of them. So let's say you have 10 you have 10 by 10 options, and there's 100 different values you can choose. That's 10,000 options. You would then do a technique called a grid search. That's one of the more common methods for parameter tuning, where you will loop over every single one of them to find the most effective parameter. That's quite a typical way. There are other ways you can use other statistical methods such as Gaussian Bayes. But yeah, in general, most models will have sort of some typical parameters that work for general cases, and you'll usually find them by just Googling and sort of just a bit of investigation into the model itself. So the 128 and 10 that I used earlier is pretty standard for a 10 output neural network. If I wanted to upgrade it to 11 classes, I would want to give it more neurons, probably somewhere around 130 maybe. But yeah, it's difficult to get it exactly right, and that's why AI scientists get paid a lot of money to get this kind of stuff right. But yeah, you want to essentially, just test stuff. Really, it is what it is, unfortunately. But yeah, no worries. If anyone else has any other questions, I'm going to sit in here for another about 10 minutes. So if anyone else has anything else they want to ask about AI, or maybe using AI in your project for HACXMAS, feel free. Any feedback on the presentation again is great. So yeah, feel free to ask. Oh, and I'll go back to this. This is the as the link to the tutorials. A neural network in R. I don't know R personally, but let me just quickly Google this and check. Yeah, okay, so in so people have done it. There is a package for R called NeuralNet, NeuralNet. Seems like it's from 2019. But yeah, it uses back propagation and other methods. But yeah, it seems like that there are ways in R to do it. I haven't used R myself personally, but it seems relatively not too bad. This library looks quite nice. If I just dump it in, this could one of the directors for the chat, please put that into the comments. Thank you very much. So there you go. That's it has a link to GitHub as well, which Yep, seems pretty good there. Just sort of mess around. If you just Google R neural network package R, it should come up with a number of them, and that's just the first one I found. Yeah. Any other questions? Also, I see what you type in the YouTube with a little bit of a delay, so I do apologize if it takes me a little bit of time to read your question and get to it. Yep, last question, go for it. And yeah, you're welcome, P. Again, if anyone has any other questions, go back to the previous slide. If you're not in the TensorFlow channel in the Slack, please join it. It's just #TensorFlow. And if you have any questions, put them in there and at me. I will. Right now, I'll put my. So that's me there. Just feel free to at me, and I will answer your question. Some materials to someone who wants to start learning about neural networks. Do you have some material to suggest that someone who wants to start learning about neural networks? That is a good question. P, I believe the chat, the comments are available because this is a live stream, so they should be available on the side when you rewatch it. Could be wrong, but yeah. So yeah, material suggests someone who wants to start learning about neural networks. So essentially, TensorFlow.org has I put in here. TensorFlow.org has a lot of good tutorials, and I would highly recommend going over them. They're really good. I would also recommend there are a number of good YouTube channels. There's a channel called StatQuest that has a very good neural network video. There's also, in general, once you go over that, the basic theory and the basic how to use TensorFlow, I would recommend then going and looking into some basic statistics about sort of, StatQuest, that's the one. But sort of the basic maths behind it. It's not too difficult. It's just basic calculus. After that, I would say go and try some Kaggle problems. I'll put all the links to this in the. I'll put a lot of the links to this in the HACXMAS Slack. But yeah, essentially, I'll find some other resources for you and put them in there later as well. But yeah, essentially, you want to follow tutorials, learn some basic stats, then do some problems through Kaggle. And I'm big now. Thank you very much. And so yeah, essentially. That's how I learned. It doesn't work for everyone, but yeah, I'll try and find some resources that I'll put in the Slack for you, Yelena. You're welcome. All right, and with that, since there doesn't seem to be any other questions, I think we will. Thank you so much for joining it. Any questions, shove them in the Slack, and I will try to answer them. Thank you everyone for coming. Have a fantastic afternoon.